solution that passes through an ordered pair, what do you do? Start at the ordered pair, exactly right. So it's at 0, -2. So if we go to 0, -2 right now, 0, -2, where does that look like it's going to be? Right about, I don't know, there's 3, so maybe 2 is like right there. Is that right where 2 is?
Yeah.
Maybe a little, is it a little higher than that? So, I mean, it looks like what 3 is going to be there, like, yeah, right about there, sure. So then what do? You start sketching, right? What's this thing going to look like? It looks like it's going to go down, right? Is it going to go below this? What do you think? No, it looks like what's it going to do? It's going to go up and then, does it keep on going up?
No, go up and down.
It looks like it goes up and down, right? How high up does it go? Does it look like it goes up? It goes up and then maybe down and then something like that maybe?
Makes sense.
Something like that? Some sort of oscillation like this?
Yeah.
Looks like a narrow oscillation. It's hard because the density of that slope field is not very high. It's kind of hard. You would need maybe a few more points to do that. Okay. So what do we think it is? So at 0 pi, what did we think it was?
0.
What is the, well, the slope is 0, y equals what?
Pi.
Looks like it's y equals pi, right? So what do we, if it's n pi, what do we think the equation is going to be?
Y equals pi.
Yes, correct. We think it's y equals n pi. It's going to be a horizontal line, and it's going to keep on getting higher. That's what it seems like. It looks like it's repeating, because look what's right here. That looks like it's y equals 2 pi. Henry, I like that a lot, actually. So instead of actually trying to match points right now, let's just write down what we know. For example, what do we know about this first one?
Well,
Always what? It's always positive, right?
And it doesn't involve y, so it should be the same.
And it doesn't involve y. That's a really cool observation. There's no y involved, right? So irregardless of what the y value is,
the same.
it should be the same. So you can, so no y means you can slide up and down. Yeah, oh, that's true, actually. That's actually all true. But yeah, you can slide up and down and nothing changes, right? So yes, that does apply, but that sometimes will not apply. Sometimes you will have a y in there and it'll change based on what the y value is. In this case, all of them are the same like that. So when you start looking, you can try to find, as you move away from the y. So as x gets bigger,
The lines
they get steeper. Yeah, so you could do that. Sure, there you go. Good. You want to be totally sound right there? I like that. That's fine. So as the absolute value of x gets bigger, the lines get steeper, right? So you can notice these things. I'm not going to run through each one of these. But you absolutely can. You told me we're going to start at the point, let's do it like this, 0, 1, correct? At that point, what is the slope of the little segment? Exactly, the slope is going to be, so the dy dx is going to equal 1. So you know you're heading in this direction, correct? The delta x is 0.1. So that means we're only going to travel along that path for a delta x of 0.1. So if I go over 0.1, how far up am I going to go if this slope is 1? Your new point right there is what? What's your new point?
1.
It's 0.1 comma 1.1. So we're at this new point. We're at that new point because we... Why isn't it just 1? Because we went over 0.1 and the slope is 1. So look, I'll show you why. This is delta x, correct? And this is delta y. We know that delta y over delta x is equal to what? The slope, right? So what is delta y going to be equal to? Delta x times what? Times m, right? What is delta x in this case? 0.1. And what's m in this case? 1. So we know that the delta y is what? 0.1, right? But what was the y value to begin with? What was the y value to begin with? It started at 0, 1. So we know it went up 0.1 as well. So we're at this new point. So let me zoom in here again. But we stop at that point. What did I call this? What's going on at this point? We need a course correction. We need a new slope. Exactly. So right here, we're not continuing anymore. We're now at the point 0.1, 1.1, and we need a course correction. We need a course correction at this point based on that starting point right here.
That's the slide now. 1.1 is on this slide.
Exactly. So dy dx now, dy dx is going to be what? 1.1. So now, instead of a slope of 1, we're going to have slight, oh, it's not a very good line segment, and my eraser's a little different now. It's a little steeper than 1, right? But again, how far over are we going? We're going over 0.1. Now we need to figure out what's our next point going to be? Ah, okay, so this one right here is this delta y is 0.1 times what? 1.1, which is going to be what? 0.11. So what point are we at right now? We're now at 0.2 comma what? 1.21. 1.21. So the idea is if you kept on doing this, what would you end up with? A path, right? We were here, and now we were here, and now we were here. Each of these line segments, so we had our first line segment right here. Here's our first line segment, and here's our second line segment. As x gets bigger, what happens to these line segments? They keep on getting steeper and steeper. They keep on getting steeper. So once again, we had our initial condition right here. We had our initial condition that led us to our second point, which led us to our third point. And it matches the characteristic of y equals ke to the 0.1. So what's our initial point? What's our initial point? So we have x. Sorry, I got to get a better marker here. We have x and we have y, right? So our initial x value is 0, and our initial y value is 0. Okay. And remember, y prime is equal to x cubed, and our delta x is equal to, it's right there, 0.1. Okay. At this point, what is dy dx equal to? 0 cubed, which is 0, right? So this is a horizontal line at this point, so it's not going up anywhere. But what's our delta x value?
0.1.
So it's 0.1, but has it gone up or down any?
No.
It has not gone up or down any. It is still at a y value of 0. What's our new y prime going to be?
0.0.
It's going to be 0.1 cubed, correct? So what's that going to be?
0.001.
Y prime is x cubed. Our new x value, and I got to get a better eraser here. I got to turn that back. Our new x value is 0.1. So what do you plug in there? 0.1. So now what do you end up with? 0.1 cubed, which is what?
0.000.
0. Yeah, there's a lot of zeros. How many zeros are there? 0.001, like that. So now we know that the...
Wait a minute.
Is that dy dx?
That is dy dx. This is the chart I'm making right here. Yeah. Okay. So the point is that is the slope at that point. Remember how delta y over delta x was equal to what? The slope, right? So what did delta y equal? M delta x. Yes. Slope is equal to rise over run. Yes. M is dy dx. Correct. At this given point. So I'm just giving you the relationship between everything here. So the first time, was the line going up or down? It wasn't. It was horizontal, correct? But now we are at a new point. Our new point, we're sitting at this point right here. Is it going horizontal? No. Technically it's going up. Little tiny bit up, right? It's going a little tiny bit up. Our new x value is really easy to find because what's our delta x value? So our new x value is going to be 0.2. So how do you get your new y value?
0.1 times the slope and added to the previous y.
Exactly. So what was our previous y value? 0. And what are we adding to that? 0.1. 0.1 times what?
0 times delta.
0.1 cubed. Correct? It's where we were, right? Plus delta y. So what is this? I'll do this again right here. It's going to be our previous y value, which is 0, plus the delta y, right? But what is that delta y equal to? M delta x, right? And what is m? What is m? 0.1 cubed, right? And what x value are we at?
So why do you use the dy dx from the last one?
Because
Why is it 0.2 cubed?
why isn't it 0.2 cubed? Why isn't it 0.2 cubed? Oh, excuse me. Why isn't it 0.2 cubed? Because we already found this right here. That's a very good question. This right here is the slope at this point, right? to find out where we are now, we need the slope at the prior point. Do you understand what I'm saying? And what do they mean?
You want it in terms of y and x.
Yeah, so what is y equal to?
What force times the force.
Plus what?
C.
Plus c. Now here's the thing. We were just looking at this. What was the x value we were looking at?
0, 0.
We started with x is equal to 0, correct? When x is equal to 0, what kind of slope should you be seeing?
0.
You should be seeing 0, right? And then it's going to slowly start spiking away, right? Because it's 1/4 x to the 4th. So for numbers that are less than 1, it's going to have a really high gravity around having 0 as its slope. Do you understand what I mean by that? It's going to be really flat for a while, and then all of a sudden it's going to take off. Does that match this table right here?
Yeah.
Yeah, it really does, because how fast is this thing growing at the beginning? How fast is it growing right
Tiny.
now? Tiny, tiny, tiny. But then look what happens. The step, the amount of change here, look how fast it's changing all of a sudden. Then what happens as you get a little bit bigger than this? It's going to what?
Explode.
It's going to blow up. Now, you see a lot of zeros here because you're adding 0.1 to this, but then why do we start getting different kinds of fractions here? Because you're going to start adding to this instead. You're no longer at a 0 value for y. What do you add instead? You're going to have the prior one, which is it's moving off of that. So yes, the idea is the exact solution is, in this case, really easy to find because they present it in a way that you can integrate. Yes, they present it in such a way you can integrate. Let's do the last part C of this. Where is it? Right here, C. Oh, so use a sketch of the slope field for this equation to explain part B. Let me go back to that. This is number 2, I think, right here. It's going to be 2 right here. Let me go back to this. It gives you the slope field, I think. Let me go to here. It does not. Use a sketch of the slope field. Let me see if I have it in the answer solution here. The slope field. Yeah, there it is. So if you actually were to use all your data and make a slope field for this thing, and by the way, you can definitely go get a slope field program for your calculator. They're really cool. It'll draw a slope field for you. Yes. I'm sorry, can you get it from Wolfram Alpha? Will Wolfram Alpha generate slope fields? Yes. Can you carry Wolfram Alpha with you into the AP exam?
No.
So here's the idea. This right here is the slope field, and you see all that? It kind of looks like a little fuzzy caterpillar right there. All they're saying is that you plot a bunch of points along the slope field, and it should match. Because what does this look like right here? What function should that be? 1/4 x to the 1/4 x to the 4th. Exactly, like that. That's a terrible way for me to write that polynomial. 1/4 x to the 4th. So the question is that you're probably asking in your head, what kinds of questions could I ask on an exam like this? I am not going to have you generate a table like that. A much fairer question are things like this, what we just did, and again, that's what your mind thinks of that right now. Something like this, right here. I could give you something where I could say the differential is rather simple. Plot the next 2 points. That's fair, because you have to understand the method to do that, and it's a lot less intensive of really. It's a lot less a requirement.